Okay, metallurgy. Okay, so there are some portion that we're going to explain you here. What is metallurgy? Metallurgy means that is a branch of science that deal with the extraction of metals. Okay, means that is a branch of science that generally deals with the extraction of metals from the earth crust. Okay, and metals generally exist in nature in two forms. Okay, metals generally exist in nature in two forms. The first form is the the first form is actually, wait a minute, let me pin my video so that the first one is metal exists in the native state, and the another one exists in the combined state. Okay, so in nature the metal exists in nature in two forms. One is the native or free state. Okay, and another one is the combined states. Okay, for example, if I'm talking about silver, okay, Ag, silver, Au, gold, platinum, they generally exist in the form of silver sometimes. Not every time it is going to exist in the native state. Sometimes, okay, sometimes it exists in the native state. Okay, gold, platinum, and combined state is that the metal exists in the in the form of stable compounds. And what is the form of a stable compound we're talking about? So, like for example, calcium exists in the form of calcium carbonate, CaCO3. Okay, sodium exists in the form of NaCl, sodium chloride. Okay, aluminium exists in the form of Al2O3 dot 2H2, bauxite. Okay, like similarly, we have zinc exists in the form of zinc sulfide, iron exists in the form of Fe2O3. So these are the reactive metals, and these metals does not exist independently in nature. They exist in more than exist in the form of a stable compound. Are you getting my point? What I'm saying right now?
Yes, sir.
Okay, and these are the some metals that are existing in the uh, pure state. Generally means if you are just finding the silver or gold or platinum, they generally found in the free state. You just need to refine it and they will get the pure state. But here some metals exist in the combined state in the form of stable compounds. Okay, understood.
Yes, sir.
So please take the right now. Wait a minute. Yes. Okay, so next is, you need to keep in mind here is that one thing that we're going to study this topic, that is in today's class I'm going to teach you only that topic which is very very important, and from which portion the mainly the in the examination the question is being to ask. Okay, so I'm not going to write means I'm not going to write this each and everything right, and you need to write it. Please take the screenshot of this portion and write it in the, because no one will going to ask you that which write a definition of combined element, okay, native state and what is free state. No, they will not ask you. They will, means you need to know this one, that some element exists in the free state, some exists in the combined state. So have you taken the screenshot of this one?
Yes, sir.
Okay, should I move forward, both you?
Yes, sir.
Okay, now moving to the next portion is, now what you will do first of all, for example, we are just studying right now that we are just studying the economical methods. First of all, you need to keep in mind that we are studying the economical method, means that will be cheaper, easy and convenient, that it will be the best way to extract out metal from the earth crust. Okay, so first of all what you need to do here is that you need to extract uh, metals from that substance which is going to have higher percentage of that element. Okay, for example, if you need to take out the iron, or you need to obtain iron, or you need to obtain iron from the earth crust. Okay, so you will choose that substance in which the percentage of iron is more. For example, if I give you Fe2O3, and another one, if I'm going you to give you the soil, the playground soil. So if I ask you that substance from which substance you're going to get more iron, so you will get more iron from this one, that is a ore. Okay, that will, you drill it into the earth crust, you will find Fe2O3. In some region it is going to have, means that for some in some region Fe2O3 percentage is more. Okay, and from that you will extract out that big hump of stones that is of Fe2O3, and then you will start. Okay. Similarly, if I ask you that you need to take out the means sodium, you need to extract the sodium. So will you be able to extract out sodium from sodium chloride? Will it is easier, or will you take it somewhere which you feel some salty substance, like for example the orange juice, which is a little bit salty, a little bit okay, sour in taste. Okay, so will you will prefer, what you will prefer? So you will definitely prefer this sodium. Okay, there are some metals, there are some fruits that contain sodium. Okay, and for example, similarly, if I ask you the iron, to which will you will choose better to extract out iron? Will banana is going to have rich source of iron, so will you extract out iron from banana, or you will extract out the iron from this one? So obviously you will choose that substance that is going to have higher percentage of that compound. Okay, of that element. Okay, okay,
Okay,
you understood? But you need to keep in mind here is one thing, that what I'm talking about is minerals. Minerals. Okay, what are minerals? First, minerals are those substances that is going to have elements in that one. Okay, for example, soil is a mineral. If it is, even if it is consisting of calcium, iron, phosphorus and other elements. Okay, whether it whatever percentage it is there, or whatever, will it be costlier or easier, convenient or not, it does not matter. If it contain iron, then it means it is a mineral. Okay, okay, understood? So I'm
yes,
having that this is a soil, the soil is also a mineral. Okay, and if I'm having this one, that is the, and that is the Fe2O3. Fe2O3. Okay, so these both are minerals because it contain calcium, iron and something, okay, some other elements also. So they are consisting of iron and soil. Soil consists of calcium and iron. Okay, and this is going to have iron, so it is rich source of iron. So we will consider this mineral as an ore. What we will consider this mineral as an ore. So what is an ore actually? Ore is that mineral from which you can easily or conveniently extract out metal. Okay, for example, if you need a water supply in your home, okay, okay, for washing clothes. Okay, so what you will like to prefer? There can be a source of water when you are just, for example, you have installed AC in your home, and the AC, from that AC, when you turn it on, the water comes out and you just collect that water. Okay, and it take a whole day for collecting a bucket of water. Okay, when you run your AC for the whole day for 24 hours, a bucket of water will be full. But if you have a pump and you have a water supply, you just use that pump, so it will take 5 or it will take 1 or 2 minutes to fill the buckets. Okay, so which will be more convenient for you? Will it be suitable that you are just installing AC for obtaining water for washing clothes, or it will be suitable for you that you are just going to have a water connection, a water supply and a pump which can gives you the water, that amount of water in 2 or 3 minutes? Which is much better? And AC will use more electricity for the whole day as comparison to the water pump will use. Okay, so what I'm saying here is that that supply of water can be obtained from AC, as well as AC drainage, as well as the water supply that you are having in your home. But the convenient is, the best way is just you need a water supply, a proper water connection, a pump in your home that will gives you water from the some similar in other stuffs. Okay, similar is that one, that if you are having minerals, if you are having a mineral can be a soil, Fe2O3 also. But the best way to extract out, the easy way to extract out iron is not this from the soil, but it is from the Fe2O3. Okay, likewise, similarly, if I'm going to have this example that Al2O3 is an ore of Al2O3 dot 2H2O. This is a bauxite. This is called BA bauxite. Okay, bauxite. And then we have those, the second one is Al2O3 dot 2H2O dot 2SiO2 dot 2SiO2. So this is an ore. What is it? It is an
oh,
ore. Oh, sorry, it is bauxite, and this is okay. But if you extract out mineral, if you extract out aluminum from this one, it is easy. It is easy, convenient, and cheaper. Okay, and this one is not easy. Okay, difficult, and expensive. Okay, so which, and both are going to have aluminium. So which do you think is an ore? Both are minerals. Both are minerals. But which do you think is an ore? Bauxite is an ore, or this is China clay? This is
So
China,
bauxite.
China clay. Yes, bauxite is an ore. So both are minerals, and those mineral from which you can extract out metals, extract out metals easily, conveniently, in a cheaper way, then we will simply say that that will be considered as an ore. Okay, you understood?
Yes,
Understood?
sir. Yes.
Sure. Kiran, you understood?
Yeah.
Okay, so let's you move this one, and you please note it down the definitions of both. Note down the definition of minerals. Minerals is those elements or compound that exist. This is that. Okay, that exist naturally in earth crust. That exist naturally in earth crust are called minerals. And what are ores? Those minerals from which metal can be extracted out easily and economically are called ores. Here is the example: bauxite, which is an ore of aluminium, and this is China clay, not an ore. Okay, but both are minerals. Both of them are minerals. So please do this one. Note it fast in your copy. Is it possible for you to both, so that I can check you whether you are writing your fixed expression, or are you getting this one? Uh, so can you please turn on your camera if it's possible? Both, because
No,
it
my
is,
camera is not working.
the camera is not working. Okay, because it is easier for the teachers to explain the things with fixed expressions if if the student is getting that one, so we can consider that one, that she's getting or not, by the face expression. Okay, and this is exactly this class become exactly similar to that of offline class. Okay, when we are able to see the face of the students. Done?
Done.
Noted? You, Kiran?
Yeah. Done.
Okay, now moving to the next portion here is, okay, now if we have an ores, for example, now what we have minerals, but from minerals we have decided which one is an ore. Okay, for example, we have chosen that we will choose China clay or bauxite. So we decided that, which is more convenient. We have decided that one, that bauxite is an ore, and we will extract the aluminium from that one. Okay, and after that one, what we will do, we have decided that Fe2O3 we have to choose for extraction of iron, not this oil. We have decided that bauxite we have to choose, not the China clay, for extraction of metals of aluminium. Okay, sorry, aluminium. Now after choosing the ore, what we need to do is, for example, if we have a big hump of Al2O3 or Al2O3.2H2O, okay, this is a bauxite ore, yeah, or it can be Fe3O4. So it is not necessary that it is going to have. What we will do first, we will convert it into, we will crush the ore. Okay, we'll crush it into thin powder. Okay, and crushing or hammering. Okay, and then after crushing and hammering, what we need to do here is that we need to, after hammering or crushing, what we need to do here is we will remove the impurities from it. Okay, for example, if it is going to have these particles, when we convert it into powder, and we convert this Al2O3 into powder. Okay, so it does not mean that 100% the particle present here is of Al2O3. Okay, no, it must contain some impurities. It must contain some impurities. That this is the impurity that is present inside it. So what we need to do here is we need to separate this one. We need to separate. We need to bring the ore, the particle of ore separately, and remove the gang or impurities from it. So what we need to do is, the next step is enrichment of ore. Enrichment of ore, or we can say the removal of impurities, the removal of gang. Gang is impurities, okay? Removal of gang. And this is also called concentration of ore. Concentration of ores. Okay, so first of all, what we will do, we will crushing. After crushing, this after deciding that the ore, which is an ore, which is a mineral, so we just take the ores only. Okay, from that minerals, we'll choose the ore, and then after we crush it into the powder. Okay, what would happen next? After crushing, we will do the separation of gang. Okay, so there are different methods for separating out the impurities from the ore. Okay, so first, what are these and what are those impurities? Oh, sorry, what are those methods? So first of all, let me explain you that there are different types of ore. Okay, one is the halide ore. Halide ore. The second one is sulfide ore. Okay, what is halide ore? Halide means, halide word come from the word halogen. Halide word come from halogen. And what is halogen? Halogen is the 17th group element. And what is 17th group? You have seen this periodic table, that it is going to have elements like one here. Have you seen this periodic table?
Yes, sir.
So the second last group, there are 18 groups. The second last group is having fluorine, chlorine, bromine, iodine. So these are the halogens. Okay. So for example, if an element is going to have, for example, KCl, for example, KCl, potassium chloride, sodium chloride. Okay. If any element is going to have or is combined with this fluorine, chlorine, bromine, iodine, then okay, PbI2. So this, we will consider this one, that this is are halides. So if they are having fluorine, chlorine, bromine, iodine, if the metals are combined either with fluorine, chlorine, bromine, iodine, then they are considered to be as halide. Okay, understood? If they are bonded, if a metal is bonded with fluorine or chlorine or bromine or iodine, then it is considered to be as halide ores. What are sulfide ores? Sulfide ores are those ores that are bonded with sulfur, like for example, zinc sulfide. Okay, okay, lead sulfide, AgS, Ag2S, Cu2S, copper pyrite. So these are the sulfide ores. The third one is carbonate ore. Carbonate ores. Okay, so carbonate ores are those ores. Okay, carbonate ores are those ores which are having carbonate group. What is carbonate group? Can you tell me what is carbonate group? What is carbonate group? Kiran, do you know what is carbonate?
Isn't it a salt? Not sure.
And you? Yes, Samira. Sorry, Samina. Do you know what is carbonate group?
No idea, sir.
This CO3 is considered to be as carbonate group. If any element is bonded with, any metal is bonded with this CO3, then it is considered to be as carbonate group. Like we have CaCO3, calcium carbonate. Okay, like we have zinc carbonate. Okay, so these are the carbonate groups if they are having CO3 at the end. And the last one is the type of ore is the oxide ore. Oxide ore are those ore that is going to have oxygen at the end, like for example, Fe2O3, iron oxide. Like we have Al2O3, aluminium oxide. Okay, zinc oxide. So these are the oxides. Okay, now we have different methods for the enrichment of different types of ore. Okay, so if I talk about the methods, note it down, the types of ore. Note it down.
Sir, can H2O be an oxide?
H2O.
Yes, sir.
H is not a metal. H is hydrogen is not a metal. So it can be, but if hydrogen is metal, but hydrogen is not a metal, so it will not be. Okay.
Okay.
Hydrogen is gas. Note it down fast.
Done, sir. Done.
Are you taking the screenshot? Still you are taking the screenshot. You cannot write this.
No, sir, I'm writing.
Okay, I'll check it in the last. Okay, next. Next, if I'm having let's suppose if I'm having uh, now we are just studying the step that is enrichment of ore, that how we enrich, how we remove the impurities. Okay, enrichment of ore. So that is enrichment of ore. Enrichment of ore. So what do you mean by the enrichment? Means removal of impurities. Removal of impurities. Okay, so this time I'm just going to write the names only of the method, but actually in detail it is not being asked in the examination because it has been cut from this time from the 10th standard. So we have different methods. The first one is gravity separation. Gravity separation or hydraulic washing. Okay. This method is used for the enrichment of oxide and carbonate ores. So oxide and carbonate ores like Al2O3, like ZnCO3. Okay, so oxide and carbonate ores are enriched. Enriched means are means their impurities are removed by this method. Okay, enriched by this method. This method. Okay, you understood? Understood. Second is froth flotation method. Froth flotation method. Okay, so froth flotation method is, this method is, we can simply say here that only this is suitable for the enrichment of sulfide ores. So only sulfide ore are enriched by this method. Have you noted?
Yes.
Okay. Next is magnetic separation. Magnetic separation. Okay. So magnetic separation is the simple way in which we have a roller like this, another roller like this, and it is a magnetic roller. This one is magnetic roller. Magnetic roller. Okay, and over it is a conveyor belt like this. Okay, and we just pour this one here. Okay, and this is the roller that is moving like this. This is moving like this, and we have, let's suppose we have ore, that is one ore which is iron attracted, which is attracted with the iron, and another ore which is another impurity which is not attracted by the iron. So this is the impurities that is not attracted by the iron. Okay. Okay. So when it moves over the conveyor belt, then this, which the things which is not attracted with the iron will not move like this. They will fall here and will they will start falling here and will move. I'll show you. Okay. This one. Okay. And the one which is attracted with the iron, still it will be attracted because it is a magnetic roller, it will be attracted. Okay, here like this, the substance which is attracted with the my iron, it is attracted like this, it will come and it will demagnetize here. It will demagnetize here because the magnetic effect will come remove from here. Okay, and it will separate, it will form a separate keyboard, this one. Okay, so this is the way of magnetic separation. Okay, understood? This is non-magnetic substance. Non-magnetic substance. Magnetic substance, and this is magnetic impurities. You understood? Understood?
Yes.
Magnetic impurity, it can be impurities or magnetic. This is magnetic substance. Okay, magnetic substance. So generally the ores which is iron, okay, is enriched by which contain iron is enriched by this method, because the ore of the particles of iron will be separated out and by this method, and the impurities which is sand and some particles which is not attracted with the magnet, they will be separated like this. Okay, so iron ores is generally enriched by this method. So we can write here this method is suitable for enrichment of that ore in which in which either the ore or impurities means gang, is or has magnet attracting property, has magnet attracting property. You understand? When you're done, please let me know. Done. So one of them, if either the gang is attracted or the impurity is attracted with the iron, so there should be one substance, either the gang, the impurities, or the ore. One of them should be magnet attracted. Okay, so the one which is magnet attracted will form a separate heap from the one that is not attracted by the magnet. Okay, you understood?
Yes, sir.
So by Froth flotation method, we enrich the sulfide ore. I'm not going to explain you what is done in the Froth flotation method, what is done in the hydraulic washing. So we are not going to explain you this one because this is not in this syllabus this time. So just I have mentioned their names only. They may be asked that which type of ore may be enriched by by Froth flotation method. So that is only sulfide ore. Okay, understood? Now moving to the next one. What we are doing, what we have done this one. So we have enriched the ore. Enrichment of ore is done. So if we have enriched the ore, then what has happened? We have removed the impurities from the one. Now in the previous one, we were having the particles of Al2O3 or something in it along with the sand particles. But now the particle of sand or impurities are separated and we are just going to have only enriched ore. We have separated this one. Okay, now we have pure ore and this is the impurities. Okay, impurities are separated. Okay, now what we need to do is the next step is after the enrichment of ore, we have the next step that what we are going to do here is we are just going to bring the ore in a suitable form. For example, if we have accept the halide ores, we because halide ores have different methods to be enriched. Okay, what we are doing here is that, for example, if we have calcium carbonate, okay, and we have zinc sulfide. So what we are going to do is we are just converting this calcium carbonate into calcium oxide and this sulfide ore into their oxide form. Why we are doing this? So why we are converting the carbonate ores, carbonate form of metals into its oxide form? Why we are converting this sulfide form of metal like zinc sulfide into zinc oxide? Because if somebody asks you or if somebody gives you that you need to extract out metals, you need to extract out metal from one is when you have a sample of calcium carbonate, another you have calcium oxide. So which will be easier for you to extract out metal from it? So it is easier to extract out metal from calcium oxide rather than their carbonate form. Why? Because it is easily reducible. It is easily reducible. It is easily reducible. Okay. So what we are doing here is we are just converting the carbonate ores into their oxide form, sulfide ore into their oxide form, and oxide ore are all already in oxide form, like Fe2O3, like we have Al2O3. Okay. So these are already in their oxide form. No need to convert it. But what we are doing, we are just converting the carbonate and sulfide ore into their oxide form. Why we are doing this one? Because it is easier to extract out metal from their oxide form rather than their carbonate and sulfide form. Okay. Understood?
Yes.
Understood? So what we are doing, bringing the next step is bringing the ore in suitable form, i.e. conversion of carbonate and sulfide ore into their oxide form. Okay, you understood? Understood?
Yes.
So this is done by two methods. Okay, one is calcination. Calcination is done for the carbonate ores. Okay, for the carbonates. And what happened in the calcination? Don't write it. I'm going to explain you first. Then I will ask you to write. Then you will write that. Okay, just explain. I just understood this. Calcium carbonate, for example, this calcination is done for bringing the carbonate ores into their oxide form, used for carbonate ores. Okay, and C for carbonate and C for calcination. And what we do here is we heat the carbonate ore in the absence of air. We are not giving extra oxygen here. Why? Because it is already oxygen rich. CaO plus CO2. Just heat it and you will get, and this carbonate ore will get converted into their carbonate forms, oxide forms. Sorry. And the next one is roasting. Roasting is used for used for sulfide ore. It is done for sulfide ore. You understood? It is done for sulfide ore. What are sulfide ore? Which is going to have sulfur at the end, like sulfide. That it is. Okay, what we does here is we heat the metals or ore, okay, in the presence of oxygen. Why this one is done in the presence of oxygen? Why this one is done? Because we need to convert into oxygen, and if there is no oxygen, we need to supply from external. Here it already has oxygen, so there is no need to have the oxygen, give the extra supply of oxygen. But here it does not have, ZNS does not have oxygen, and if we need ZNO, then we need to supply the oxygen. Okay, plus sulfur dioxide. So this is done for sulfide ore. For example, if I'm having PBS and we heat it in the presence of oxygen, then it will convert it into PBO plus SO2. You understood? Understood?
Yes, sir.
What are the advantages of calcination and roasting? Advantages that first of all, it get converted, it help in the conversion of carbonate ore into their oxide form and sulfide ore into their oxide form, because it is easy, because which are oxide forms are easily reducible. Means reducible means that removal of oxygen from this calcium oxide is easy from their oxide form rather than their carbonate forms. So we will simply say that since oxide forms are easily reducible, or we can remove the oxygen from that one in an easy and convenient way, so we are just converting the carbonate ore into their oxide form. Similarly, the sulfide ore is converted into their oxide form. Carbonate ores are converted into their oxide form by a method called calcination, and sulfide ores are converted into their oxide form by a method called roasting. Okay, roasting, you can understood that this is done in the presence of oxygen. Roasting a chicken in a something, so it is done, it does not be done, don't do the vacuum there, we just roast it in the open air. So it simply means that roasting is, we need an extra supply of oxygen because we need to convert. Okay, so simple is that way you can learn it. And what is the other advantage of this calcination roasting? If suppose this calcium carbonate still have some impurities, which is in the form of which is volatile impurity. Volatile impurities means that if there is some substance which, just listen to me very carefully, if there are some substance which is going to have low, which can melt at low temperature, because this require high temperature at 900 degrees Celsius. Okay, so if there is some volatile impurities which can melt at low temperature, for example, if it is having something which can melt at low temperature, okay, so that volatile impurities can be easily removed, because it can be melted, and it can be easily comes out while you are eating this one. Let's say, for example, at 400 degrees Celsius, that impurities get melted. So that impurities will be slided, or will be easily removed from that one. Okay, when we have, like, we have a sloping something. Okay, and we are doing calcination here. So if this is the carbonate over here, okay, so if it is having some impurities and we are just having fire here, okay, so if this having some volatile impurities, so these volatile impurities can be easily melted and comes out, separated out. Okay, and there will be only calcium carbonate. So if there is some volatile impurities, some humidity is there, so that can be easily separated out from this one. Okay, so what we are doing, what we are doing in calcination roasting, we are just converting the carbonate ores into their oxide form in calcination, and in roasting we are just converting the sulfide ore into their oxide form. And why we are doing this one, why we are converting the carbonate ore into the oxide form, the sulfide ore into their oxide form, because it is easier to extract out metal from their oxide form rather than their respective carbonate and sulfide form. Okay, you understood?
Yes.
Understood. So let you write it, please. Let me show you. So please note it down. Note it down. Why we are converting sulfide ore and carbonate ores into their oxide form? To write it down. It is easier to extract out metal from their oxide form from rather than their carbonate and sulfide form. Note it down. When you're done, please let me know. Okay.
Done, sir.
Yes, you also. Kiran, done?
Yeah, just one second.
Okay.
Yeah, done.
Okay. Now note down the definition of calcination and roasting and their advantages. Done.
Sir, give me
Done.
1 minute.
Okay. Done.
Done, sir.
Done. Other. Okay, you are done.
Yeah.
Okay, done. Okay. So let's move further. Now we're just going to study the very important part of this chapter. That is, after doing that, we have learned that how we did the calcination roasting. Okay. So there is the next one is if we have converted the oxide form, carbonate forms into their oxide forms and sulfide ores into their oxide forms. Like we have CaCO3. First we remove the impurities, okay, by using gravity separation, and then we heat it and we convert it into the oxide form. Okay, like we have ZNS, and we heat it, okay, it get converted into ZNO. Okay, now we have everything in their oxide form except the halide ore. We are talking about the halide ore because they are okay, they are not used, we are not going to use, means they will be studied at last, okay, because they are very highly reactive. So if we are having this calcium carbonate, we have just converted into calcium oxide. If we have zinc sulfide, or we have converted into zinc oxide. Okay, if we have PBS, then we have converted into PBO. Okay, and if we are going to have anything, any O, Fe2O3 is already in the oxide form. So we have just converted everything in the oxide form except the halide ores. We'll talk them later. Okay. So now what we have done here is we have converted the oxides over, sorry, carbonate sulfide ores, and oxide is already in oxide form. So we have just converted everything in the their oxide form. So now what is the next step is reduction. Reduction means removal of oxygen. Okay, reduction means removal of oxygen. So how will we remove the oxygen? So I'm just writing here. This is the potassium, sodium, calcium, magnesium. Okay, so if we have KCl, sodium chloride, CaCO3. Okay, so we have already converted CaCO3 to CaO. Okay, magnesium oxide already into magnesium. Okay, magnesium. Then aluminium we have converted into Al2O3. Okay, then we have chromium oxide, Cr2O3 and MnO2. Okay, like we have next one is zinc oxide. Zinc is found in the form of zinc sulfide and zinc carbonate, but we have converted this zinc sulfide or zinc carbonate, the two towards this we have converted by simple heating. We converted it into ZNO, and we give it by roasting. We convert it into ZNO. So if we have zinc carbonate or we have zinc sulfide, we have converted into form of CNN. Okay, then Before that, I'm just writing here carbon, okay, and then when we have ZNO, okay, then we have PbO. If we have PbS, then we have converted into PbO. Okay, after zinc we have iron. Fe2O3, then we have PbO, okay, lead oxide, and after that one we have hydrogen here, and below hydrogen we have Cu2s, copper copper pyrite. Okay, this is an ore. I'm just writing here ore. Then Ag2s. Okay, HGS, sorry, HGS and Ag2s. Okay, and gold and platinums are found in the pure state. So these ores can be converted into their oxide form. Okay, into their oxide by simple roasting. By simple roasting. These ores can be converted into their metal form by reduction with carbon. Reduction by carbon. Okay, because I have written carbon here, it means that these ore can be these need some reducing agent. Okay, let me explain you first what we am saying here. That if you have Ag2s, let's suppose Ag2s. So what is done in the roasting? You heat the element in the presence of oxygen, you convert it into, it will be get converted into Ag2O plus sulfur dioxide. Now further, if you heat Ag2O on continuous heating, it will gives you Ag plus O, oxygen gas will be removed. Okay, though you are just simply heating it, phosphate get converted into oxide, and then oxide continuously, if you heat it, it will get converted into silver. Okay, you understood? Understood?
Yes.
So this is the for the silver. Similar for the Hg, O, HGS. When you heat it in the presence of oxygen, it will also get converted into HgO and then sulfur dioxide. And when you further heat it, HgO continuously, if you are heating it, okay, when you continuously heat it, then it will, okay, then it will get converted into Hg plus O2, means pure mercury you will obtain, okay, by simple heating. Got it? So their oxide form will be get converted into, you will get the metal by simple roasting. Just keep on roasting it, it will get converted. Okay, are you getting my point? Are you getting? Please note it down. Note it down fast. Make this table also. Till your class will start after 6 minutes, 4 minutes, okay? 4 to 5 minutes. Done, noted?
1 second.
Yeah, done.
Now, what we are doing here is, note it fast.
Done, sir.
You also?
Yes,
Kiran?
sir. Done.
Yeah.
Okay, so now this is, now the third we are having this one. Just listen to me. This is important. Okay. So first for this one, let me explain you for. These are the low reactive metals. These are the low reactive metals. Okay. So low reactive metals can be obtained. These are the low reactive, which is copper, silver, and mercury. Okay. Gold and platinums are existing in the native state, so no need to. And these are the mid reactive metals. These are the mid reactive metals. Okay, mid reactive. So they are reduced by carbon. What I'm saying here is that, let me explain you what I'm saying. For example, if you have ZNS, okay, you simply heat it or roast it. It will gives you ZNO plus sulfur dioxide But like in the least reactive metals, you are hitting ZNO, and if you continuously heat it, it will not gives you Zn plus O2. No, it will not gives you. You need some reducing agent. You need some reducing agent. And for that, we use carbon. We use carbon to reduce it. Okay. We use carbon to reduce it. What we use? We use carbon because these are the reactive metals and their bond between oxygen and zinc is very strong. So you cannot reduce it. Okay. So when you heat it with the help of carbon, then it will gives you zinc plus carbon dioxide will be released. Okay. So here we need an external reducing agent, that is carbon. Okay. Similar for the mid-reactive metal is Fe2O3. For example, if it exists in the form of Fe, FeS. So first you heat it in the presence of oxygen, then it will gives you Fe, Fe2O3, and then sulfur dioxide. And when you heat it, if you try to heat it Fe2O3 and you want to get Fe, you will not get it. Like in silver, you were getting that. If you heat AgO, Ag2O, if you heat it continuously, then it will gives you Ag plus O2. No, in this case, it will not happen because the bond is strong. So what is going to happen here is that we need some reducing agent, and for that we have carbon. Okay, for that we have carbon. So mid-reactive metals are obtained with their oxide forms can be reduced with the help of some reducing agent, that is carbon. But coming back to this one, copper, if we are talking about this copper, okay, so this copper needs some reducing agent. And what is that? Let me explain you. For example, if you have Cu2s, copper, this is very, very important. Okay. If you heat it in the presence of oxygen, that is simple roasting. So by roasting you are doing, okay, when you heat it, it will gives you Cu2O plus sulfur dioxide. But if you try to heat it alone, it will not gives you Cu2O, Cu like in silver it was giving, and sulfur dioxide. It needs some reducing agent. It need some reducing agent. And like we are using carbon for this one, it can be reduced with the help of carbon. But here, one thing you need to note it, that here the crushed ore itself behave as a reducing agent. Means some of the particles, for example, this is the particle of Cu2s. Okay. And this is the particle of Cu2O. Okay. So what is happening here is that this alone cannot gives you Cu. This alone cannot gives you Cu. If you heat it, it will not give you Cu plus SO2. It need a reducing agent. And what is that reducing agent? That reducing agent is itself a crushed ore. Cu2s. Cu2s. Okay. Crushed ore itself behave as reducing agent. You understood? Crushed ore itself behave as a reducing agent. What I'm saying here is that it will react when some of the white particle get converted into brown. Okay, then this brown particle again start reacting with the white particle, which is not been converted till yet. Okay, they are slowly, because some of the particle get not instantly. If you add some popcorn to this one, that every popcorn is converted into the means every corn get converted into popcorn. No, there is slowly process. Okay, similar is that when some of the particle get converted into this one, then this particle will start reacting with this one. Okay, you understood? And slowly, then here this Cu2s will form Cu plus SO2. So there is no need to bring some external reducing agent like carbon. There is no need for that. Okay, here we don't need external reducing agent. Crushed ore itself behave as a reducing agent. Okay, you understood? Understood?
Yes, sir, understood.
So for today's topic, you will be given